My name's Marc Whitty. I'm a lecturer in robotics at UNSW, and we had a very interesting start in getting into viticulture. So no viticultural background, but for the last 3 years we've been working on a major project for yield estimation. Surprise, surprise. Very much the same as Carlos's presentation just before, so we'll be very keen to see. First question, how many of you have been to Sydney? A few? Oh, good. Well, the rest of you are welcome to come, all right? It's a lovely place. Please come and visit us in Australia, and we'll take you and show you some very nice vineyards as well. They're a little bit far away. Our closest vineyard's about 5 hours drive, so that makes things complicated. Anyway, what do we actually do here? So UNSW is an engineering-focused university with around 55,000 students, quite a number of schools, ranks in the world's top 50. So that's where we are, where we stand. What do we use that for? So I'm the leader of the Smart Robotic Viticulture Group, or SRV. I know it mentions robotics, but today we'll be talking mostly about viticulture. So we have a team of postdocs and students working together for a number of these outcomes. Now you've just seen some point clouds generated from LiDAR. Back in 2010, we were invited to take our robot on the left. We call him Harry. Anybody seen Harry before? No? It was built for robotics competition, and we took it to a vineyard and we decided, let's see if we can use a LiDAR arrangement with RTK GPS, just exactly the same as Carlos has mentioned, to generate point clouds of vines. We published a paper then, and 3 years later we had an inquiry from Treasury Wine Estates to say, hey, we want to work on a project and estimate yield. And we said, great, okay, let's jump in. So we did. And it ended up getting a lot of funding from the Wine Australia, the research institute or funding body in Australia. And now we have 3 funded projects and another one we work on as well that I'll talk about today. Now, one of the things with putting robots in vineyards is, well, let me ask another question. How many of you own a robot? A few? 3? Vacuum cleaner robots? No? What? Cleaning? No? Okay. Anyway, have you tried to actually use it or do anything with it? They're kind of complicated. So given that they're complicated, we thought, well, let's just take the robot out of the equation and see what we can do just using an existing vehicle. So here we have a gator, any kind of farm vehicle, and our first approach was, let's mount purely a GoPro camera. These things you take to the beach, you take surfing, you take skiing on either side of the vehicle and see what we can do. Now starting in about 2008, Steve Nuski in the US did some very good work on image processing for yield estimation. But the device he built was quite large and expensive. We thought, let's try it with something similar. So we use the GoPro devices. We can stitch or process the images together. And once you get an image, this is at the shoot stage, we can then process that to try and count the number of shoots. And once we've done that, because you generally drive the same pattern through the vineyard, up and down and up and down and up and down, if you know the outline of the block, without using GPS, we can give you a map of the yield potential or predicted yield in the block 5 months prior to harvest. That's before we even have flowering, before we have bunches, just shoots. So there you can see, there's one of our vehicles with the camera, one on either side. And this is what you see. So we've made some unsupervised learning and classification algorithms, so no training required, that are able to work in different conditions. There's a paper we've just recently had accepted. Same algorithm running in now daylight or not very cloudy conditions, just simply counting the number of shoots on the vines. And what happens? You get a map that looks something like this or something like this, 2 different blocks, one about 6 hectares, the other one about 10 hectares, and you compare 5 months prior to harvest with what you get at harvest. Now I'm not going to say that's perfectly estimate, but you're starting to get a pattern of which area of the block has higher yield and which area has lower yield. Some people say it's consistent year to year, some people don't. what you'll notice is that if you take an aerial PCD map around Veraison, that does not necessarily correlate well with the harvest yield map. This is from an on-harvest weigh scale monitor. So we're saying, well, how about doing this earlier? You might get better results. So here's what we have at the moment. Our estimate for the total yield that year was 63 tonnes. It turned up as 69 tonnes in that particular block. And that, of course, relies on a lot of prediction factors, estimated bunch weight in particular. So we are estimating a long way out. That's what we have for yield estimation. We also did a little bit of work on bunch detection. This algorithm is automatically learning the number of features and then classifying bunches. This is from an American vineyard where the bunches are very visible. So that makes our job a lot easier there. Another project we've looked at is vine water stress. We've heard about this a lot. Hands up, how many of you have problems with water in vines? A few? Not a lot? Well, in Australia, water supply is a major problem in many areas. So many of the vines are irrigated, and knowing how much water to apply is really critical. So many of you would go out there and use pyrometers or pressure chambers, pressure bombs to measure what's happening. And so what we've done is we've tested a number of technologies that use, or the aim is to use smartphones to collect this data from various points. And one of them is using microscopic imagery. So this is leaf peels with nail polish on the bottom of the leaf. You peel it off, you put it under a microscope, and we're using learning algorithms to detect the number of stomates in the image and then do some fitting to each one of those stomates to try and detect the opening of the guard cells there to see how much water is being transmitted in or out to give you an estimate of how stressed the vine is. Now, there's a lot of factors that go into that, and you viticulturists can tell me how I can do better at that, but from an image processing perspective, we're able to get these and get decent relationships. Another approach to water stress is to use thermal cameras, the FLIR devices like the FLIR 1. You can buy quite cheaply, plug it in, or you can even buy a phone with it built in. We've developed an app that's being beta tested with farmers now around Australia, whereby they go to the vineyard with the phone, they take a photo of the canopy, the app will automatically process the photo, detect where the leaves are and extract anything else or remove anything else, identify a couple of reference surfaces which we've placed in the image, identify them automatically in the image, and using those reference surfaces, generate an estimate of the crop water stress indicator, a commonly used one for thermal measurements. The aim of this project has been to see how easy it is for farmers to go out and use it, rather than showing the actual whether the algorithm works. But the algorithm does work. The farmers are using it. This is data in a back end. We can show you it's live from across Australia, a lot of our test sites. If you zoom in, you can click on each one of these images. You'll get all the data associated with it. So we have the entire processing pipeline from mobile phone to web server to user interface as well. And just think about that with your applications. Is there something we could collaborate on to use that kind of pipeline for farmers that's quite easy to manage? How many of you do yield estimates by counting berries? A few? Good, I've got some customers. Because we've made an app that can automatically count the number of berries on a bunch from a single photo. So one of my PhD students, or now a postdoc, Scarlett Liu, developed an algorithm that takes a single image of a bunch, like this, and estimates the 3D reconstruction of that bunch from a single image. It's an estimate, but we're getting accuracies of just over or just below 10% for counting the number of berries on a single bunch. If you average that across quite a number of bunches that you take photographs of, then you'll be able to estimate how many berries you have, well, possibly in the vineyard. So we've turned this into an app. It's being developed and tested at the moment. You can see the various stages of the algorithm, from the image processing through to the reconstruction. And this little simulation which I think it's going to play, just gives you an idea of how you might want to use it. You take a photo, it's uploaded to the cloud. Within the cloud process, it's going to detect the number of berries. It's going to give you an estimate of sparsity. We'd offer that free, and here comes the hook. If you'd like the disease detection or the more advanced algorithms, then you start to pay for a service beyond that. So there's a lot more work that can be done there. Match it up with GPS locations, and you can start to build models of what's happening at different points within your vineyard, and use that for estimating which blocks you need to harvest in order based on their current yield. Another thing we've looked at is tracking bunches. So this is all in vivo work, where we've tracked 80 bunches in each block for a period of every week or 2 weeks throughout the entire season. So this is the same bunch each time, one example from each of 4 blocks, and you watch it over time and see how it progresses. And you can clearly see which are white varieties and which are red varieties, going to turn into red varieties. So just monitoring those over time, and we have a lot of that data available to process. So if you'd like to work with it, please come and have a chat. We've got lots there if you're interested in image processing of bunches. So we also looked at flower counting, and you've probably seen Javier's app for Vitis Flower for counting flowers before. We actually looked into ways to try and improve it, and are getting some slightly better results for counting just the number of flowers. So some better correlations between visible flowers and the total number of flowers. And I'm sure we'll talk to Javier later about ways to collaborate and improve that. The accuracy for the flower counting is around 80 to 85%, and this is accuracy against manually stripped flowers. And if you've done that, you'll know how ridiculously boring it is. So if you can automate that process, then we can go a long way to making farmers' lives easier. We've tested this across 4 different cultivars and many hundreds of images across a number of locations. One of the things to notice there is when you are testing something like this algorithm, and here we have different data sets across the top and the same data sets down the side, how does the accuracy vary? If you test on a subset of your data set and then extrapolate to the remainder of your data set, here we're testing on 13 images and extrapolating and calculating the accuracy across about 70 images, you get accuracies of 85 to 90% within a single variety. If you then train on, let's say, second Chardonnay and then test on a Shiraz block, on a Shiraz variety, then you'll find that the accuracies vary quite a lot. So we believe there's not a global model you can use for estimating the number of flowers from a single photo or a single image of a particular bunch. But there's more to come. This should be published very shortly, some work in this area. We've also been looking at maturity estimation. So a lot of people have been talking about that today. And one of my PhD students is looking at using a multispectral camera to detect the various chemical parameters that are necessary for estimating the maturity of the bunches. So very early stage work, but using off-the-shelf sensors that can estimate across a very large scale, so driven along the rows, to get the maturity of the entire block using just RGB cameras or modified variants of that. The correlations we get within a single variety you can see here on these particular plots, and I can show you more detail later if you like. We've also looked at visible berries versus the whole bunch, because even though you can see the berries, doesn't mean they're representative of the entire bunch. For Shiraz, it would seem that they're quite a good relationship, but for the Chardonnay, the relationship is not particularly a one-to-one ratio. So you need to take that into consideration when estimating your bunch maturity. Another project we've looked at has been estimating where in the vineyard you have missing vines or non-bearing foliage, or non-bearing sections of cordon. So I've used some UAVs with the commercial program to stitch the imagery together from RGB and near-infrared data. And then the red sections of these particular rows are where we've detected non-bearing cordon. In one particular block, that was up to nearly 20%, due to trunk diseases. In the following year, they were able to do wrapping on to improve that and reduce that to about 6%. But we're getting quite good accuracy in terms of comparisons with ground truth across the block and our estimate for non-productive canopy, just from aerial imagery. That pretty much concludes my talk today. If you've got any questions, we'd love to collaborate, and of course you're welcome to come to Australia. It's a lovely place. So please do come, and we'll look forward to seeing you there. Thank you for your attention.